Hello, in this video we learn about multi-threading and multiprocessing, okay, and some programs, sample programs. Before learning multi-threading, just we have to know what is thread, okay? What is thread is? A thread is a small unit of execution within a process, okay? A process can have multiple threads running independently. In simple words, a thread represents a separate path of execution of a group of statements. Okay, in a Python program, we write a group of statements, then the statements are executed by Python virtual machine one by one (PVM). Okay, this execution is called nothing but thread because PVM uses a thread to execute these statements. This means that in every Python program, there is always a thread running internally, which is appointed by the PVM to execute the program statements. Okay, so thread is a small unit of execution within a process. Multiple thread means multiple thread execution. We'll see later what about this one. Okay, and before learning multi-threading also we have to know difference between the single tasking and multitasking. Okay, so in single tasking only one task is given to the processor at a time. In single tasking only only one task is given to the processor at a time, whereas in multitasking multiple tasks is given to the processor at a time. Okay, multiple tasks, but in general to achieve multitasking we need multiple processors, but you can achieve multitasking through single processor only, but slight time delay will be there, okay, compared to the single tasking. Okay, and also you have to and also there is a difference between the process and thread. You have to know the difference between the process and thread. What is process? Process is nothing but a program. Okay, process represents a group of statements which are executed by the PVM using a main thread. A process represents a group of statements. Okay, group of statements will be there now. We will execute in the normal Python, which are executed by the PVM using a main thread, and also each process will have its own memory, a program counter that keeps tracks of the instruction being executed, and a stack that holds the data. Okay, each process will have its own memory and program counter. Whereas thread also represents a group of statements within a program, but when we have to create them separately, which are in turn run by main thread. Threads will not have own memory. Process will have own memory and program counter. Threads will not have their own memory and program counter. The data of one thread easily shared by another thread. Okay, if threads can share the data easily. Okay, that's the reason we call it as thread is not safe, because one threads data have thread can share, means thread can share data between the threads. Okay, the data can be shared between the threads, which communication will be there between the threads, and data can be shared. That's the reason data can be not be thread safe. Whereas process is generally not available to another process. Okay, process data is not generally available to another process, so unless both the process of communicate explicitly. Okay, but and then why we use threads, why we are using threads? Okay, so threads are highly useful when we want to perform more than one task simultaneously. Okay, threads are highly useful when we perform more than one task. What task we'll see later. Simultaneously, this is also known as concurrent programming. What is concurrent programming? Concurrency here is, concurrency. Okay, multi-threading allows you to run multiple threads concurrently within the single process. Each thread has its own execution track, but it shares the same memory space, making it suitable for tasks that involve IO operations or tasks that are not CPU bound. Okay, and also threads are mainly used in server-side programs to serve the needs of multiple clients on a network or internet. On internet, a server machine has to cater to the needs of thousands of clients at a time. Okay, for this purpose we have, if we use the threads in the server, they can do various jobs at a time, and thus they can handle several clients. Okay, so because that's the reason we have used threads. So this is the interview question: why we use threads? Means threads are mainly used in server-side programs to serve the needs of multiple clients on a network or internet. Okay, and okay, like that. And also we can use threads in the animations, also games and animations means moving one object to another. In simple animations, suppose the guy is shooting. In animation, in games, the guy is shooting and walking. Okay, so if you take walking as one thread and shooting as another thread, okay, we can say that both threads are working simultaneously. While walking, she's shooting now, so such a way. Games also, threads will be there. And also concrete, I told threads are not safe because to make threads safe, hence PVM use an internal global interpreter lock, GIL, global interpreter, because threads are not safe here. That's the reason PVM introduced this global interpreter lock. So there is a global interpreter lock that ensures only one thread executes Python bytecode at a time. This means this is that multi-threading in C Python may not fully utilize multi-core CPU or CPU bound tasks. However, it can still be beneficial for IO bound tasks. Okay, so to make threads up, this PVM introduced this global interpreter lock, okay, because only one thread takes place Python byte daytime, okay, not multiple threads. So that's about the threads. These are the theory, okay. Multiple processing means involving multiple process, okay. So multiple tasks you can achieve through multiple processing only. Multiple, if you want to achieve multiple tasks, you can achieve through multiple tasking only. You can achieve through single process also, okay. Multitasking can achieve through single process, but they take some time consuming, okay, compared to the multiprocessing. So that's about the theory part, and we will learn more about while doing program, okay. So you can understand better, okay. But you have to understand one thing: thread is a, what is thread? Introduction question: what is thread? Thread is a smallest unit of execution within a program or process, okay. Single process, smallest execution means, you know, in a function, sorry, in a class or in a program, different functions will be there. You can assign thread to each and individual function, okay. That's nothing but a thread. Each and individual function nothing but a thread, okay. So to communicate, you can communicate with different functions through threads also. To different function through threads. Okay. Threads are used to achieve concurrent execution, means simultaneous execution, allowing program to perform multiple tasks simultaneously. Each thread represents an independent sequence of instructions that can run concurrently with other threads within the same process. Okay. To achieve concurrent execution, okay, to achieve multitasking, threads we will use simple words. Okay. To achieve multitasking and to achieve concurrent execution, you have to use threads here. This is the first program. We will do it here. Write a Python program to find the currently running thread in a Python program. Write a Python program to find the currently running thread in a Python program. So I have to know which thread is running in a current program. Okay, which thread is running, I have to know it. For that, if you want to work with the threads, you have to import it. Okay, like this one. Import threading module. You have to, if you want to working with threads, you have to import this threading module. Okay, import threading. And next thing is, first we have to, okay, let us find the current thread. Just, okay, print it, this one first, initial print. Okay, so we have to find the current thread, which thread you are running. You have to know which thread you are running, okay. And find the name of the present thread. You want to find the name of the present thread. So current, what is the current running thread? Okay, current running thread. And there are two methods will be there from threading module. We have to use that threading dot current thread. Okay, so know the name of that, you have to use get name. Simple. Okay, using current thread you can know the which thread you are running. Which using, you want to know the current thread name also, you can get like this one, threading dot current thread or get name. So you get the current thread, nothing but a main thread. Okay, check if it is main thread or not. This obviously, if threading dot current underscore thread equal to threading. So whenever you remember, whenever if you want to check any condition, you have to use if loop. Okay, if loop is very important. Suppose if you want to check condition, if you have to use if or while. Okay, while main thread. Okay, check if threading, for loop is used for the looping. If you want to loop it, you have to use for loop. If loop and for loop are very important. Okay, in any programming language, if and for loop are very important. So you have to practice that, you have to understand. Right. Okay, the current thread is the main thread. Else print it's not main thread. Okay, just simple. Okay, print not main thread here. Execute it. Okay, just wait it. We are checking. I hope this is a simple programming only. So let us find the current thread. Current thread is the main thread. The current thread is the main thread. Okay, the simple to know which thread you are running. This is a program about the to know which thread you are running. Okay, simple one. You have to use a threading module. That's important here. You have to use the, if you want to work with it, you have to use a threading module. You can use import threading, or you can use like this also. from threading import star. Okay, so that all method you can import it. So you can remove this threading here. Okay, no need of right here like this threading here. So you can remove it here threading. Okay, so you can write like this also. Okay, two way you can write this way also. You can import it. Okay, from imports from threading import star means all methods and all variables you can import it. Okay, so this is the just to know the which thread. Okay, to know the which thread you are working, this is a program about it, simple program only. So there will be another programs also there. Write a Python program to create a thread and use it to run a function. Run a function. This here see t is equal to thread. Okay, while continue. To create a thread in Python, there are three ways will be there. Okay, to create a thread in a Python, three ways will be there. First way is creating a thread without using class. Okay, the second program. Third program is nothing but creating a thread by creating a subclass to thread class. Okay, and another fourth programming, creating a thread without creating subclass to thread class. Okay, in one way we will see. First way we will see. Okay, second programming, creating a thread without using a class. Without using a class, how we use thread we will see in this programming. And this is the syntax here. Remember, t is equal to thread. Okay, thread here, and target is equal to function name, means which function you want to apply threading. Okay, which function you have to apply threading, you have to write here function name. And if there is any argument, you can write argument here. Okay, argument is equal to argument comma argument 2. So these arguments will pass to the function parameters. Okay, so at last you have to use if you want to start the threading, you have to use t dot standard. Okay, t dot start method. To run the thread, you have to use t dot start. To assign the thread, you have to use this one, t equal thread target equal function name in Python. Okay, so simple program only we'll see. Okay, this is one way. Without using class, we are using creating a thread without using a class. Okay, remember, creating a thread without using a class. Simple programming. Just here use a definition. Write any function name here. Display. Uh, Pass. Okay, parameter, any parameter. Okay, parameter will coming from the thread now. So print str. Okay, and creating a thread that run the function 5 times, something like that. Create a thread that runs a 5 times. How you create a thread? How you create a thread that runs the function for 5 times? Using for loop only, no? If you want to run the function for 5 times, you have to use for loop here. Okay, for an I in range 5. Okay, and syntax. Remember syntax. Okay, t is equal to thread. Okay, target is equal to, what's the function name? Target. You have to remember the syntax. Okay, target is equal to function name display. Okay, target is equal to display comma. Okay, here display spelling wrong here. Display, and also argument is there, no? One arguments. Okay, equal to tuple. This is a tuple argument. You can write it hello or whatever. uh, Creating Python or something, whatever you can write it. Creating Python without using class. Simple, whatever. Okay, without using class. I have to write couple. Okay, comma after that because it is tuple. And start the thread. Okay, how to start the thread? T dot start. Assigning the thread, start the thread. Okay, you have to remember, assign the thread assign the thread to the function. Assigning a function thread to a function, and also starting the thread. Starting the thread, you have to use this t dot start method. Okay, this is way of creation. This is without using a class, creating a thread. Okay, without using a class, creating a thread. Okay, we are created t thread here, and we are starting the thread now. See, creating Python without using class 5 times it executed here. So this simple syntax. Okay, remember syntax. This you have to remember the syntax. Okay, here remember the simple program only. Just I want to ever use it to make sure understand this syntax here. Target is equal to display. Target is equal to display arguments. Okay, which function you are applying, you have to write in target is equal to here. Okay, name, and arguments equal to which arguments you have to pass it through the function parameters. Okay, this without class. Okay, remember that one. And next third program is write a Python program to create a thread by making our class as subclass. Okay, our class as subclass here. Okay, write a Python program to create a thread by making our class as subclass to the class. Okay, this is second way of creating a Python threading. Creating a thread by creating a subclass to thread class. First way of creating a thread is without using a class. Second one is way of using the way of creating a thread is creating a thread by creating subclass to the thread class. Okay, we are creating class now. Earlier program we did not use a class here, but we are using class thread class. We are using a thread class here, and we are creating subclass here. Creating a thread by creating subclass to the thread class. Thread class obviously parent class. Subclass whatever you did, you have to import inherit it. Okay, we have to inherit it, and we have to override the run method in superclass. Means that means thread class there is a run method will be there. We have to override that one. Okay, functionality we have to override that run method, and you can write any task in the run method, and you have to create instance of you have to create an object of the class and start running the simple. Okay, so first we have to create any class name. Create any class. Okay, class name. Create any class name. Class my thread. Okay, and then as I told, you have to know the inheritance for this thread is here. Thread is a superclass. Okay, my thread is a subclass, so we are inheriting properties from this superclass. There is a run method will be there in the superclass. We have to override that one. Okay, so how we override it? Simple, define run method self obviously and repeat any task. Write any task. Suppose I'm writing 5 in range 5. Okay, print I. Next one, create an instance of my thread class. Create an object means create an object this class. How you create object? Simple, t1 is equal to my thread. This is a way of creating object. So successfully we create this class object, and we have to start this one now. T1 dot start. Okay, T1 dot start. That's it. T1 dot start. Simple. Okay, so we are not using threading syntax here. Just we are using superclass thread class. Okay, superclass thread class. We are importing the run method. So we are overriding the run method of the superclass, and we are creating the instance. We are executing. This is simple, no? This is the second way of creating a thread here. This is 0 1 2 3 4. Okay, this is the second way of creating a thread. And another program is a write a Python program to create a thread that access the instance variables of a class. Instance variables of a class. Okay, same program only, but create a thread that accesses the instance variables. Means instance variables of a superclass. Superclass there is an instance constructor will be there. No, creating a thread by creating a subclass to thread class only. Constructor that calls the thread class constructor. Okay, if you want to call thread class constructor, superclass constructor means you have to write this syntax here. Thread dot init self. Okay, thread dot init double underscore init underscore self. Okay, override the run method of the class, create and same thing. Okay, so same thing. Just so if you want to access the superclass constructor, how you access the superclass thread constructor, you have to access like this one, thread dot init dot self. Okay, right. Same program only right here. Define you have to write constructor, no, definition init construct self comma str, pass any comma str. Okay, pass any variable. So now you have to pass the not access the thread class constructor. How you access? Syntax I have told, no, thread dot okay, thread dot init, okay, thread dot init, and the in parenthesis you have to write self. To access the superclass constructor, you have to write this syntax here. Okay, means superclass constructor variables. If you want to access a superclass constructor variable, you have to access simple next self dot str is equal to str. Simple. Override the run method here. Override the run method. Just instead of writing task, just print self dot str. Okay, that's it, and pass any this is write any writing here, overriding any argument here, overriding superclass thread constructor. Okay, thread constructor. How to access superclass thread constructor using this syntax here. Okay, simple. So we are writing a superclass thread constructor. So while creating an object, this will assign this value to this variable, and we will access it. Okay, to run method, overriding method, we'll access that method. Okay, simple. See, overriding super simple one. You have to understand. Okay, how to access superclass constructor variables and methods using thread class. Okay, using subclasses and thread classes, how you access superclass constructor and superclass methods, superclass, and how you will override methods here. Okay, so this is a simple second way of second way of passing, second way of creating a thread. This way you can create a thread, and also there is another one is it join method is there. Okay, so many times it is better to wait for completion of thread by calling the join method. Join method uses for the it is better to wait for the completion of thread. Okay, by calling the join method. If you want to wait for the completion of the thread, you have to use join method. So the join method just simple. You have to write like this one, t1.join. That's a simple. Actually, no need for this small program. If you are writing any big programs, you can write this one. Okay. So come by wait, just wait for completion of it. That's it. Nothing change here. Okay. In next class, next programs, we'll see about join method. Just remember. Okay. Wait for the thread class. For waiting purpose, you have to use join method here. Okay. How we will wait, we'll see in the classes. And this is we have seen two ways of creating a thread class. Okay, next we'll see third way. Okay, the three ways of creating thread class. So this is the third way here, writing a Python program to create a thread that acts as an object of a class that is not derived from the thread class. Okay, so creating a thread without creating the subclass to thread class. Okay, first one way of creating a thread means without creating a class. Second way is with the thread class. Third way is creating a thread without creating a subclass to thread class. We'll create now without creating a subclass to thread class. How we will create it, we will see here. Okay, how without using a thread class here. Second way with using thread class. Third using without thread class. Okay, simple. You have to define constructor and instance method. As usual, you know how to use constructor and instance methods. Create an instance of a class and pass any string. Create a thread to run a method of object and run the thread. Simple thing. Simple thing only. So here we don't want third way. This we have to don't use third way. We don't want to use this thread class here. So we have taken out thread class. Simple, and take out this also. Okay, and okay, and pass any arguments here. Self comma x. Okay, whatever arguments you can pass it. Print dot self dot str and print arguments or args are comma x. Okay, how many any number of arguments you can pass here. Okay, so, pass to these parameters here, not run here. Run is display, write any another method display. Okay, simple. Okay, the simple constructor, simple method. Okay, self comma x accessing mode. So now create an object here. Okay, create any object. So t1 is equal to my thread only, creating an object here and passing this thing over class, overriding superclass and constructor. You're not overriding the superclass constructor, no, without using thread class, without using without using thread class. Okay, without using thread class. So this is the object here. Okay, This is not T1, write any obj, something like that. This is an object. We created object now, okay, by passing this argument. So now we have to create a thread. How we'll create the T1 is equal to thread. So what's the first parameter? Target is equal to, what's the function name? obj.display. We have to access, so if you want to access instance method, you have to access through object only. obj.display here, display, comma. Any argument equal to args is equal to just one only, no, just we have just one or whatever. You can write it 10 pass into this argument, okay, this function argument we are passing here 10, and by creating an object we are passing this object argument. Start the thread. How we start the t dot start? Simple. 932 self dot run. Mm-hmm. Which type error? Display argument. What's the difference? Was there any problem? Okay, constructor method. Okay, so write in brackets here. What's the problem? You need correct only. Display self comma x, okay, self dot str, write everything, print, okay, whatever arguments we are passing this, we are writing here x, okay. Next we are creating an object, okay, my thread object here. Let's see this one, my thread only, yes, and we are passing an argument here, my thread class, okay. T1 is equal to thread, where target is equal to object dot display, fine. Ox is equal to 1k. What's wrong here? Line 932 self dot run. Okay, pass another argument here. Everything is same, no? Right. Yeah, args are 10 comma 20. Without using a thread class, args are 10 comma 20. Okay, this is the third way of creating threads. Okay, you can create a thread without using a class. You can create a thread with using thread class. You can create a thread without using the thread class. Okay, so this is without creating a thread class. Simple. Okay, we have created constructor, instance method, and we have created object, and we are accessing through method object, target element, and we are passing our start. Simple. Okay, so I think now you remember three ways of creating threads. I know, just you have to okay, how to create threads. Okay, it's simple. This one, okay, how to create a threads. Three ways of creating threads. You know how to create. Just use a target is equal to function name, or if there is any argument, you can pass the argument. Okay, this is right. Simple one. Next program. Write a Python program to show single tasking using a thread that prepares T. Single tasking program. Single tasking. You know, single tasking means it passes one task at a time, one task to one process, okay, one task to the process for processing, not multiple tasks, and the processor and the another task waits until the processor executes the first task. Okay, so single tasking, this is used. Okay, so a thread can be employed to execute one task at a time. Suppose there are three tasks and these are executed by thread one by one, this is called single tasking. Okay, so let us plan a program here. Preparation of tea in three steps here. Okay, boil milk and the tea powder for 5 minutes, one task, and second task is add sugar and boil for 3 minutes, second task, and third task is the filter it and third task. Simple. We write all the three functions in a single method. single method, and we'll call this 3 methods. Okay, simple program only, single tasking. Okay, to achieve single tasking we are doing this one simple. First we have to write method that perform the task and define the 3 threads, and also use sleep method we have to use here. Sleep method sorry, sleep function here, the temporary sleep function is the temporarily suspends the execution of running thread, means it stops the running thread execution of running thread for a specific time given in seconds here. Okay, sleep method suspends the execution of a running for a specific time. If you want to stop your thread for execution, you have to use this sleep method. Okay, if you want to stop your execution for some particular time, you have to use this sleep method. Remember that one. Okay, and sleep method is if you want to use sleep method, you have to import time from time module. Sleep method will be there, sleep functions will be there. Okay, so we'll write this one single tasking. Take out all this, and I told now you have to import. If you want to use sleep, you have to import time module. Okay, now we have to class my thread some prepare, right? Prepare, that's it, simple. Preparing tea, that means preparing a tea, self, and write 3 methods. Okay, here uh, wait 1 minute, and write 3 methods here. Define sorry, self dot task 1, another method self dot task 2, self dot task 3. So we have to define these 3 methods now. Okay, first one, define task 1 self. So what will be the here, just first task, what is the preparing tea, first job, first task for the what, just we boil, have to be, no, boil milk, and tea powder for 5 minutes. Okay, end is equal to, means this end is equal to cursor would moves to the next line, simple. So you have to sleep 5 seconds. I'm writing here 5 seconds only here because if 5 minutes means takes more time, no, just 5 means 5 seconds only, sleep 5 minutes, 5 minutes means 5 into 60 into 60 you have to write it. Okay, but I'm writing, sir, 5 into 60 I have to write it, but I'm writing here just 5 seconds only for quick execution. Print done. After 5 seconds it's telling it's done. Okay, repeat same program for, okay, this is the next task 2 here. So what's that, preparing a tea, next task, add sugar and boil for 3 minutes. Okay, add sugar and boil for 3 minutes. Okay, here also I am using, instead of 5 I am using 3 seconds. Okay, 3 minutes 3 seconds only I am using. So next also same, what's the task 3 here, task 3, just filter it as of, that's it, simple. Okay, filter it and serve, so no need of sleeping here, no need of stopping the sleeping is stopping the execution, stopping the task execution. That's it. So no need of sleep here. Done. Okay, that's it. 3 tasks here. Okay, now we have to create object to this class. How you create? Simple. Obj is equal to my thread, and now we have to create a thread here. Okay, t is equal to thread. Okay, and target is equal to, so here third way we are using way of reading accessing through object dot what's the function name? Prepare comma, that's it. Prepare only, no arguments here, just prepare here. Okay, and start the thread. Simple, just preparing. Okay, in prepare method we are calling these 3 methods here. So to achieve single tasking we are using this program. Simple program, just to understand it. Okay, write it. See, waiting for 5 seconds. Done. Another wait second, 3 seconds, and it will add sugar in 3 seconds and it will return. Okay, so to understand sleep, to understand sleep method and achieve single tasking we are using this one. Okay, to understand the sleep method, sleep function. Okay, because we wait 5 seconds. No, if you did not use sleep seconds, you do not wait it 5 seconds. So this programming is achieving single tasking. Next thing is multitasking. Okay, next program is multitasking. This is a single tasking. Next is multitasking here. See, write a Python program that perform 2 tasks. Earlier program is single task using 2 tasks using 2 threads simultaneously. Okay, this is nothing but multitasking. Okay, so in multitasking several tasks are executed at a time, because executed at a time. For this, because in earlier programming, see, one task at a time. No, not if 3 tasks are there, so one after waiting for some seconds another task is executed. But in multitasking several tasks are executed at a time. For this purpose we need more than one thread. If you want to achieve multitasking, you have to know, you want in multiple threads. Okay, for example, to perform 2 tasks we can take 2 threads and attach them to 2 tasks. Okay, to achieve 2 tasks we can take 2 threads and attach them to the 2 tasks. Okay, then those tasks are simultaneously executed by the 2 threads. Using more than one thread is called multi-threading, and multi-threading used in multitasking. Simple. And we'll use this. How, what's a program? First you have to write define constructor and method, and we have to create a 2 instance of class. Means we have to create 2 objects of the class. With objects same, we have to create 2 threads and run 2 threads. Okay, we have to create to achieve multitasking, to achieve multi-thread, to use multi-threading and achieve multitasking we have to use 2 objects, 2 threads. Okay, to run 2 threads. How we will see, we'll see. Okay, how, this is a simple example. We'll write it. We will write a simple theater programming example. Theater, in movie theater will be there, no example. In movie theater example, there will be one person will book the tickets, another person will show the your seat. Okay, the booking seat. So we'll see that one. We'll cut book ticket and the showing seats. How we perform simultaneously, because for single tasking only one person will be there, only one thread at one process at a time, no, one task at a time. So only we have to book the ticket, and that person has to show the chair, and another person has to wait for the book the ticket until that first person finishing his job. Okay, that is single tasking. In multitasking you can have 2 threads. Means one person can book the ticket, another person show the ticket. Okay, that's it. So how we'll see this program. So first we will write the constructor here. Define init self comma str. Okay, constructor, constructor everything. Okay, I need not explain again. Okay, constructor and method, write an instance method. Write a method that repeats define movies. Okay, movie theater example. Okay, function and self will be there. Obviously self is a variable that knows the memory of the object location. Okay, for I in range 5, print self dot str comma I. The str will pass through the object. Okay, the string variable will pass through an argument, and just sleep. Okay, for every loop just sleep for 1 second, sleep for 1 second. Okay, and now create an object. Simple object, one object obj1 is equal to what's my thread. Okay, one person will book the ticket. No, book ticket booking, one person will book the ticket here. Okay, obj2 object2 is equal to my thread show chair. Another person will show chair. One thread, one object will book the ticket, another object will show the chair. Now we have to create the thread. T1 is equal to thread T1 is equal to thread target is equal to, what is the target? obj1 dot movies. Okay, simple. Target is equal to obj1 dot movies. Another T2 is equal to thread, what's the target? Target is equal to same ob second object obj2 dot movies. Simple. And start T1 dot start start a thread, two threads. So I hope you understand this program. Okay, so because we are creating two objects of this class, and we are creating two threads here, not one thread, two threads. Earlier we are using only single threads, now we are using two threads. To achieve multitasking we have to use two threads here. Okay, to achieve multitasking you have to use two threads here through these two objects. Okay, means we are in simple words, we are creating a threads for a single function, two threads. Okay, single function we are creating two threads here. See, for single function only, object1 dot movies, object2 we are creating two threads through two objects, two different objects. So to achieve multitasking, okay, multitasking we have to create two threads here. Okay, so one person will be the book ticket and one person will be the show chair, and we are looping this one. Okay, looping this one and reassigning. See the output, and see book ticket 1 show chair 1 show chair 2 book ticket 3 show chair show chair. So if you see this you can understand here. See, if you see the output here, book ticket show chair. Okay, fine. Second one also book ticket and show chair. Okay, fine. But third one you see, the loop is not repeating sequence. Okay, it's showing show chair book ticket. Okay, here see there's a problem here. Okay, for multitasking in threading there's a problem. This problem is nothing but a race condition. We call this as race condition. Okay, race condition is a situation that occurs when threads are not acting in an expected sequence. Okay, that leading to unreliable output. Okay, race can through thread synchronization race condition can be eliminated. So what is thread synchronization we'll see in the class. Okay, see, because and remember, okay, I'm telling again this program for multi-threading. If you want to achieve multi-threading you have to use multiple tasks, multiple threads you have to use for the single, to access for a single object we are accessing thread to multiple threads through different objects. Okay, so next thing is for this, but there is a problem will be there using this, because in sequence the output will be not be in sequence. Okay, the output will be say here show chair put together is not sequence of here. If you want to change sequence multi-threading. Using multi-threading, you have to for you have to use thread synchronization. Okay, you have to know the thread synchronization. So what's the thread synchronization? Write a perform. Okay, so next program is about the thread synchronization. Okay, the problem which arises in this one we will solve in the next coming programs. So this write a Python program where two threads are acting on the same method. Okay, same method to allot a berth of a passenger. So this is about a thread synchronization. So how to achieve thread synchronization? How to achieve output sequence? We'll have to know. Okay, so this is write. Suppose we write some program. We'll see the output and we'll check where to achieve how to achieve this thread synchronization. Okay. So here write a constructor that accepts number of available berths. Okay, this is a train reservation about the train reservation example. So first we have to write a constructor that accepts number of available berths. Okay, available berths means you want to create a berth variable here, available variable. Next one, write a method that reserves berth. Okay, and display number of available berths. Okay, so method you have to write it, and wanted variable you have to write it. If the available greater than wanted, allot the berth. Find the thread name and display the berth is allotted for the person. Make time delay. How you make time delay? Using sleep function. Okay, so the taken number of berths. Create an instance of railway cars and specify one berth available. Okay, so create two threads and specify one berth is needed. Give name the thread and other threads. Okay, uh, while writing you can achieve this one. Okay, so while writing the program you can understand it. Excuse me. So now write a constructor. Okay, write a constructor that accepts number of available berths. Define underscore init self comma available. Okay, self dot available is equal to available. Okay, so we are constructed number of available berths we are created constructor. Okay, next a method that reserves berth. Okay, we are write method now. Define reserve method and self comma wanted. Display number of available berths. How we display? Print available number of berths is equal to comma self dot available. Okay, so if available greater than wanted, allot the berth. Okay, if self dot available greater than or equal to wanted. Okay, so find the thread name. If you want to find the thread name, we have used in first program. Name is equal to current underscore thread uh, dot get name. Okay, to know the thread you are running name. Okay, you are giving that name and display berth is allotted for the person. How you display berth is allotted for person? Print percentage d berth allotted for percentages. Okay, not comma and percentage wanted comma name. And next thing is, so make time delay. How you make time delay? So the ticket is printed. How you will make time delay? Sleep 1 second, that's enough time delay. Okay, and decrease the number of available words. If you decrease the number of available words, because if one person is booked the ticket, certainly you have to decrease. So minus equal to wanted. simple one program. uh, Else no birds, no birds available. If birds are not there, no birds available. Okay, if but no birds available, simple one. Okay, so in reserve method, first we have to know how many number of available birds are there. Okay, it will display number of birds. If the available birds is greater than wanted, means if the available birds greater than wanted, if suppose one bird is available, two birds available, and if the one available, if any person booked one, means two greater than one, means current what the current thread will return the name, and but percentage d allotted to percentages. Okay, means that birth alert, that one birth allotted to this name person. Okay, current thread name, and sleep for 1 second, and decrease the self available. Okay, birth available decrease by one thing. Okay, looping here. Okay, if looping, not looping, just decreasing by one number. Okay, now just use the create instance here. Create object. How you create object? Create an instance to railway class. Here my thread class will be there, so we'll make it as railway class here. Railway class. Okay, how you create object to the railway class? Simple obj is equal to caps lock railway, and write only one birth available. Okay, one available birth only. Just write one available birth. Okay? This one we are passing one, and we are assigning this to constructor here. One available birth. Yeah, and create two threads and specify one birth is needed. Okay, create two threads. T1 is equal to thread thread target is equal to obj dot reserve, comma aux is equal to 1 comma. Okay, simple words. Means we are passing one argument here. Reserve one wanted argument, means passing one available birth, and wanted one birth here. Okay, for first thread one thread, for second thread also same. T2 is equal to thread okay, T2 is equal to thread target is equal to obj dot reserve. So you can write multiple threads for single method. Okay, comma aux is equal to one only, for this also one only. Okay, thread, and you have to set name no for the thread, first person, to set name to the first person. Okay, T2 dot set name second person. If you did not reset the name, it will return some other name. Okay, some other thread name here. Okay, because here we will the written name is called current thread. No, we are setting name to this first person and second person. Okay, so name is called current thread get name. We'll get the first person letter name here. Okay, otherwise you can get the current thread name here. If you want to replace the current name, you have to assign this set name. You have to replace with this t1 dot set name, and start the thread. How you start the thread? How you start the thread? T1 dot start, T2 dot start. Okay, so for thread synchronization we are using this program, but it will not achieve thread synchronization. Just example only we are taking, because see we are passing one argument to this constructor, one available. Okay, available equal to 1 here, and we are passing one argument to this method here, wanted, means First person wanted one berth is there. First person will book the ticket. Second person will be book the ticket. One berth will available. We'll see the output how it executes now. First of all, RG. Okay, oxygen. See, available number of births equal to one birth allotted for person. Available number of births equal to one birth allotted for second person. See, I think we will use it here. Sleep for 3 seconds here. Okay, you can understand better here. Sleep 3 seconds. Yeah, after second loop, okay, it repeating line, so it doesn't matter. I hope you understand. Okay, available number of births equal to 1. Okay, because we are passing one birth allotted to the per person. Available number of births equal to 1, and second birth also same one, same. Okay, one birth allotted for second person. So here what is that? See, the output of the this program is not correct because the thread T1 and T2 are running on the reserve method of railway class. Okay, T1 T2 are run method reserve on the railway class. Since we have taken the available number of births as 1, when thread T1 enters the reserve method, it sees available number of births as 1 and hence it allots to first person and displays okay one birth allotted for first person. Then it will sleep for some 3 seconds here. In this time, the ticket will be printed on the printer when the first thread is sleeping. Thread T2 also enters the reserve method and it is also sees the thread one birth remaining. So the reason for this, it is available number of births is not yet updated by the first thread. So the second class thread also sees one birth as available and it allows the same birth to the second person. So then the thread T2 will also go into sleep state. Thread T1 wakes up first and then it updates the available number of births as self dot available equal to wanted here. Okay, means it updates here. So now available number of births will become 0, but at that time the second thread has already allotted the same births to the second person also. Since both the threads are acting on the same object simultaneously, the result is unreliable here. Okay, uh, so there is a problem here because one thread because the thread works here only one birth is available, but two persons are asking simple words. Two persons are asking for single birth. Okay, this program two persons are asking for single birth. If the first person book the first one berth, second person also books same time. Okay, one berth here. Okay, first person book the one thread, second person also before updating also before updating the self data available wanted, it shows no, because the available bus still available one only, second person book the ticket, so it tries the problem here. Okay, so what's the solution of the problem? So for thread synchronization, it means if the solution to the problem is nothing but a thread synchronization. So if you want to, because here see available number of births equal to 1. Okay, one birth allotted for first person. So if one birth allotted per person, second person will be 0 now, the thread has the program railway class has to be 0, but in the meantime second person also book the ticket, also book the birth here. Okay, so same birth will not allotted to the two persons here, same birth will not be allotted to the two persons. So because if one person book the birth, that another person should has to wait it. So how you wait it? Through thread synchronization. So when a thread is always acting on an object, preventing another thread from acting on the same object is nothing but a thread synchronization. Okay, so simple words. See in a program, you see here, to achieve thread synchronization, when a thread is already acting in an object. So when a thread is already acting in one object, if thread is active, preventing the other thread from acting on the same object. Suppose if one thread is acting on some one object, other thread has to wait it. That's nothing but thread synchronization. Okay, when a thread is always acting on an object, preventing any other thread from acting on the same object is called thread synchronization. So thread synchronization using following techniques: using locks, using semaphores. Using locks means we can create a lock by creating an object of lock class like this one. First we have to create a lock, and to lock the current object we have to use l dot acquire. If you want to unlock the release object, you have to use l dot release. Okay, method acquire method, release method, lock method. So lock method used to create the lock, acquire method used to lock the current object. To release the locked object, you have to use the release method here. Okay, l dot release, l dot creating the lock, acquiring the lock, releasing the lock. So we have to do, because why we are using this lock method means, and one thread is acting on one object, the other thread has to wait it. Okay, to wait other object, you have to use this locking method. Otherwise if one in the meantime only second thread also access to the first object. Okay, so how you achieve this one? locking method. We'll see one by one, same program only. See here, we'll see the output should be like this. If available number of births equal one birth, if one birth is allotted for one person, second birth has to 0. Okay, second, if second person want to book that birth, it has to show 0 here. Okay, but here is showing 1. So for that we are using thread synchronization, because same thread object should not be, so thread should not act on working object. Okay, so how you create a log object here in constructor only. So how you create self dot, so I told no L is equal to lock. Just we are creating the lock here, lock object. So L is a lock object here now. So we have to lock the current object. Where to lock the current object here? Just in first words only. Self dot L dot acquire to lock the current object. Okay, we are locking the current object, and we have to release the object. How you are release the object here? Simple. At last, okay. Self dot L dot release. Okay, simple. That's it. Through locking method, you can achieve thread synchronization. Thread synchronization is nothing but if one object is acting on a thread, one thread, the other object has to wait it. Okay. See, when thread is already acting on object, preventing any other thread from acting on that same object is nothing but a thread synchronization. To achieve thread synchronization, we have to use locking methods. Lock method, lock method. Now you check the output here. See the first output and see before output. Now see the second output here. See, available number of birds equal to 1, 1 birds allotted to 4%, available number of birds equal to 0 here. Okay, no birds available here. See, if one person has booked the birth, okay, another person if you want book that birth, it has showing 0 here. In the earlier program without thread synchronization, it's showing 1 here. Okay, but in if you're using locks and acquire method, release method, so it's showing 0 here. I hope you understand here. First program, in earlier program without thread synchronization, the second thread also using the first object. Okay, accessing the same object, because accessing the same, because available number of births equal to 1, first person is booking the birth here and second person also showing that birth is available. If you use thread synchronization, okay, for if locking acquiring, because the one thread cannot act on say object that is running. Okay, until it finishes that thread object. Okay, so you have to remember the syntax. When a thread definition here, thread synchronization means when a thread is already acting on an object. When a thread is acting on an object, which thread is acting on an object here? One thread, t1 is equal thread object dot resolve. This one is acting on one, this thread is acting on object, preventing other thread from acting on the same object. Okay, this t2 thread also same object here, because we are creating only one object here, not two objects here. Okay, so preventing same object, if you want one thread is acting on this object, if you want to stop another thread to acting on the same object, you have to use the thread synchronization, otherwise problem arises. Okay, see, this thread is acting on the same object, so another thread also acting on the, if you and another thread has to stop until this thread release a lock. Okay, using locking method we can achieve thread synchronization. So that's about thread synchronization. So there is next program is about a deadlocking of threads. Deadlocking of a threads, you can use another one, you can use also semaphore also. There is a semaphore, means semaphore also there, no? Using semaphores also we can lock it. Instead of lock object, you can create semaphore. Okay, instead of L is called lock, use L is called semaphore. That's it. Okay, semaphore is nothing but an object that provides synchronization based on counter. Okay, a semaphore is created an object of semaphore classes. L is called semaphore here, counter value, whatever counter you can write, 0 or 1, whatever. Okay, so try it. Instead of L is called lock, you can use L equals semaphore. That's it, simple. But most of the use lock mechanism only, locks here. Semaphore used for the how many locks is there, you can know the how many locks are there. Okay, So next program, to achieve deadlock, write a Python program to show deadlock occurs due to locks on objects. Because sometimes if you use thread synchronization, if you use locking system, deadlocks some deadlocks will arise. How it means, when a thread has locked an object, okay, suppose a thread is locked an object and waiting for another object to be released by another thread, and just another object is waiting, okay, to release a thread, and the other thread is also waiting for the first thread and to release the first object. Both the threads will continue waiting forever. Okay, there are two objects will be there. One object is waiting for one thread, another object also waiting for the second thread. First object is waiting for the second thread, second object also waiting for the first thread. So if it arises, deadlock arises. Okay, that's a deadlock. Okay, one object waiting for another object, and the another thread also waiting for the first thread to release the first object. Okay, one thread is waiting for the another one object, and another thread is also first thread is waiting for the one object, and second thread is also waiting for the one object. Okay, so there's nothing but the thread locking. Because even if we synchronize the threads, there is possibility of other problems called deadlock here. Okay, so here daily thousands of people book tickets in trains and cancel tickets also. Okay, if a programmer is to develop code for this, he may visualize that booking tickets and canceling them are in reverse procedures, and he will write these two tasks as separate and opposite tasks. Okay, and assign two different threads to do this task simultaneously. Booking tickets and canceling tickets involve train and compartment, which we consider as two objects. Okay, we will see with an example. You can understand here with locking how deadlock arises. Means it will stuck here. The program is stuck there. If we read deadlock. CLS. Okay, these are about the deadlock here. Okay, use railway only here. Same problem. Uh, okay, and first, how you create a lock object? L1 is equal to lock. Okay, two lock objects will create it now. So how deadlock, this program is about how deadlock arises. Okay, two locks we have created successfully. Two locks were created. So first create a function for booking a ticket. Definition book ticket. Okay, just about the book ticket. Okay, and L1 dot acquire. Okay, locking the object now, locking this object now. L1 dot acquire, first lock object acquiring. So print book ticket lock train. Next thing, print book ticket wants to lock on compartment. Okay, next one, print and I will tell you what is everything. So first L2 dot release. Okay, releasing the locks here. Next function definition, cancel ticket. One is for booking ticket, same ticket, and where next one is a canceling ticket. Okay, first one is a first function about the booking ticket, second function about the canceling ticket, same ticket, cancel ticket. So L2 dot acquire. So this program about the achieving the deadlock means stuck in the program. Simple words. Means, see here, locking. We are creating two locks here. One person will book the ticket and cancel the ticket. Okay, so we are locking the object. We are creating the thread here. T1 is equal to thread target equal book ticket, and cancel ticket starting the program. And when booking ticket, we are locking this object with L1. Okay, L1 lock. Okay, book ticket lock or train. Book ticket wants lock and compartment. If you want to book the ticket, it will book the train first. You will book the train and book the compartment. Which compartment? For fifth compartment. Okay, so up to that you have to they will lock it until it will print these two. It will lock the L1. Okay, using L1 this object. And next one is acquire. Next also next locking with L2 lock. Okay, book ticket locked compartment. Okay, so after locking locked compartment, it will release the two locks here, L1 dot release, L2 dot release. Okay, if you want to cancel the ticket, if you want to cancel the ticket, it will acquire first. It will cancel the locked compartment. Cancel ticket wants locks on train, and cancel ticket locked train. Okay, and cancellation of ticket is done. Here first one booking ticket is done. Right? It print booking ticket is done. Simple. Okay, booking locker compartment after two releases, booking ticket is also done. After two releases, this cancellation are done. It will stuck program now because see from the output we can we'll see first output here stuck now. See, observe here. See here, book ticket lock train, cancel ticket lock compartment, cancel ticket wants lock and train, book ticket wants lock compartment. It is stuck it here because two locks because we can understand that the further execution of the program is halted and booking and cancellation are not done. Booking and cancellations are not done because these are deadlock of threads. When a thread has locked an object and waiting for another object to be released by another thread, and other thread is also waiting for the first thread to release the first object, both the threads will continue waiting forever. This is nothing but a thread deadlock. Okay, when thread deadlock occurs, any further execution is stopped and the program will come to halt. Thread deadlock is a drawback in a program, the programmer should take care to avoid any such deadlocks. There is any solution for deadlock? No solutions, because there is no solution for the deadlock here, because there is no, it depends on the logic used in the program. You have to solve yourselves here. Okay, by program you can see you book ticket lockout train, and cancel ticket lockout compartment, and cancel ticket wants to clocks on train, and book ticket wants to lock on compartment. So there here lock will stuck here, both locks come together and it will stuck here, both are waiting. Okay, L1 is waiting, L2 is also waiting. So here deadlock arises, both locks are waiting, both threads are waiting for the uh, for their locks to release their object. Okay, both threads are waiting here for the locks to release the object. So here how can we achieve thread deadlock here? How can you achieve how can you solve this problem? Simple one. To achieve deadlock, there is no solution for the deadlock. Okay, to achieve there is no specific solution for the problems of deadlock. It depends on the logic used by the programmer. The programmer should design this program in such a way that it does not uh, does not form any deadlock. Okay, so to achieve this program you have to use L1 dot acquire, L2 dot acquire, L2 dot release. Here L1 dot, instead of releasing L1 dot release, use here L2 dot release. First you release L2 lock 2. Okay, then release lock 1. Okay, and acquire L1, first one, L1, and cancel L1 to L2 dot acquire, L2 dot acquire, L2 dot release. You have to follow the sequence here. Okay, L2 dot release, L1 dot release, first one. Okay, first we have to release L2, and next we have to release L1. Okay, simple words. If you're using you're locking the object in L1, if you are locking the two objects in a sequence, we don't want to lock L1 here first. Okay, we have to lock L2 first. Suppose if you lock three locks here, L1 dot acquire, L2 dot acquire, L3 dot acquire, we have to release that locks based on the sequence, L3 dot release, L2 dot release, L1 dot release. Okay, so if you do like that, you can deadlock won't erases. Okay, so that's one. See here, book ticket log train, so everything in sequence it followed here, so no deadlock here. Okay, simple words. That's about the deadlock. Next program about the communication. Okay, next programs about the communication. This the 12th one. 11th one we have seen just now, avoiding deadlocks. 12th program is write a Python program where producer, it's about a thread communication. Okay, consumer thread communication with each other through a boolean type variable. Means this variable, whatever variable you can write a boolean type variable. Okay, thread communication, threads communication. No, as I told, threads will communicate with each other. Okay, data can be shared also with each other, threads. Okay, how possible? There is three ways possible for thread communication. This is the first way. 12th program is, so in some cases two or more threads should communicate with each other. For example, a consumer thread is there. Okay, one consumer thread class is there, waiting for a producer to produce the data or some goods. When the producer thread completes production of data, then the consumer thread should take the data and use it. Okay, so in some simple words, one class is producer data, another class want to use the data. Simple words, that nothing but a thread communication through thread. So how we will see with an example. See, first we will create a producer class. Okay, and create a constructor instance method of that producer class. Producer class produces a data. Okay, here. Okay, so like this one, and we will assign some boolean type here. Inform consumer class that data production is completed. To inform the consumer class the data production is completed, you have to use this variable data prod over data production over, simple words, data prod over equal true. Okay, so and next create consumer class, and same create constructor and instance method, and sleep for 1 milliseconds as long as data provider is false. Okay, so display the content of the list, and when data production is over, create producer object and consumer object, and pass. If you want to link both classes, you have to pass producer object on consumer. Okay, if you want to link, some linking should be there, no, to thread communication. So you have to use this is the linking, create producer object and consumer object, and pass producer object and consumer. Okay, and create producer and consumer thread to run the thread. Right, here simple. First we will get producer class, and we'll see how it fares. Okay, class producer, and list here. Okay, so create one list variable and assign some data prod over equal to false. Okay, this assign this variable to false first. If the production is completed, assign this to true. Okay, assign this variable to true. That's about the constructor here. Next one, method. This is a method here. In method, what you do means create 1 to 10 items and add to the list. Okay, some items you created and add to this list. How you add the items to this? Using append method. Okay, first you create 10 items. How you create? Just use for loop, simple 5 in range. Not 10 items, use 5 items enough. Okay, as of now 5 items is enough. 5. Okay, and range in 5. And how you append this? Using self dot I dot list dot append I. Okay, and sleep for 1 second or 2 seconds. Just okay, and print some item produced here. Okay, and if it is if the data production is completed, make the data equal to true. So that's about the producer class. Okay, so this is a program about the thread communication, how two different threads communicate each other. Okay, so first we have producer class, we have created some instance variable to constructor and created a list variable. In method instance method, we using for loop, we created some 1 to 5 values and we are appended to this append method and first 2 seconds. Okay, suppose if after looping finishes, the producer class finishes the tasks. Okay, and next task is to send the producer class to the consumer class consumer class here. So in consumer class, use prod self dot prod is equal to prod. What is prod? We'll see later. Okay, just we are saying one variable. Okay, we are saying just one variable here. Okay, and next one, define consume method here, self, and repeat while loop here, while self dot prod dot data prod over is equal to false. So if it is false, means data variable data production is not completed. That means data production is not, over is not completed, then then sleep for 1 second, sleep for 1 second. Okay, if it is finished, okay, then sleep for 1 second. Suppose if it's finished, while okay, self dot list here. Okay, add to the list here. Okay, production dot list here. Simple. That's about the consumer class. Now create the objects, two objects. Producer class p is equal to producer. Okay, c is equal to consumer, and pass the producer object as parameter to the consumer object. Okay, consumer parameter. Create consumer object and pass producer object as a argument to the consumer class. Okay, and create producer and consumer threads. T1 is equal to, this is about thread communication. Okay, thread target. So what's the p dot produce, t2 dot thread target is equal to, okay, c dot produce, c dot consume, t1 dot start, t2 dot start. So I hope you understand here. This is about the thread communication, how two threads communicate with each other. Okay, so in first class we have written the constructor, we have written the method, and some task here written using fn, using list. We want to pass the data. If the data has finished, if the task has finished, you have to assign this variable to true. In the consumer class, we are receiving that production data. Okay, the data what a producer, we are receiving the consumer data, printing it here. So to link through these classes, we have to use pass producer object as argument to the consumer class. Okay, so that you can access this list variables here. Okay, you can access this list variables here through production variable. You can access this list variable and also function this method here. Okay, this list method here. Okay, this produce method here. Okay, so creating two methods here, creating two threads communicating with each other. See, we'll see the output how it works. Item producer, item producer. See, wait for no looping, wait for 2 seconds here. Okay, item producer, and at last it is 0 1 2 3 4. Okay, 0 1 2 3 4. This is a producer class, this is a consumer class. Okay, so first 5 lines in the output are displayed by the producer class to indicate that items are being produced, and after the 5 items are produced, the consumer thread takes the list and displays the contents of the list in the last line. Okay, but there is a not efficiency will be there. To improve the efficiency of communication between the threads, okay, there is some time delay will be there between, because the consumer class has to wait, because we are using this variable, no, because this variable is there until it checks for every 1 second, it checks. Okay, every 1 second it checks the data provider variable, checks the in the producer class whether data is finished or not. Okay, if it is true only, it prints the list here. So there is some time delay will be there. So to improve the efficiency of communication between threads, Python provides two important ways for this one. They are notify and wait methods. Okay, notify and wait methods, and queue to improve timing. Okay, communication between threads. So there is time delay will be there, because every 1 second it has to check it. Okay, it has to wait for some time. So to not wait immediately, you want to execute the programming. So here we have to use this 13 program. Write a Python program where thread communication is done through notify and wait methods. The condition class of threading module useful to improve the speed of communication between the threads. The condition class object is called condition variable and is created as here condition object module will be there. So condition module, there are two methods will be there, notify and notify all. Wait methods will be there. Three methods will be there. So notify method is useful to immediately inform the consumer thread that the data production is completed. Okay. And notify method useful to inform all waiting consumer methods and once the production is over. These methods are used by the producer thread. Wait method terminates when producer invoke notify all methods. Wait methods, wait is consumer class in the notify method for producer class. Okay. These two methods, notify method and notify all method used for the thread effective communication between two classes. Okay. So how we will use it, we'll see here. Same program only, but we are using, instead of a data provider boolean variable, we are using the notify and notify all methods. Okay. So here first we have to create the variable. No, take out this one. So condition class is there. First we have to create that object for that. Self.cv is equal to condition. Okay. See here, the condition class of threading module, some threading module condition class will be there, is useful to improve the speed of communication between the class. So this condition class object is called condition variable, and this create class like this one. And in condition class of three methods will be there: notify, and wait method. Okay. To improve the speedy communication, we have to use this condition class. Okay. And the condition object is created. Now we have to use the notify method, where we will use the notify method, and we have to, if you want, you have to log the method also. If you can log this one, so using simple self dot cv dot acquire, using cv also objects, you can log this one, log the condition object and notify the object and notify the, take out this one. So notify the object here. Notify means tell that task has come finished. Okay, the data production of data is finished. Notifying the consumer class. Okay, notify means notifying the consumer class the data production is finished in the producer class. Simple. Okay, in simple words. Self dot cv release. Okay, release the lock now. So notify methods, remember notify methods, locks have, you have to use the locks and between the, let's see, notify method, you have to use notify methods between the acquire and release methods. Okay. So release method, simple one, and similar release. Next the consumer class. So to get lock on the condition object here, consumer self here, self dot cv dot, no self dot production here, no prod dot cv dot acquire. Okay, and wait for that time. Well, instead of while loop here, just wait here. Okay, take out this one. So self dot prod dot cv dot wait method means it will wait until notify method notifies the data has been allocated. Use a timeout here means immediately, time equals 0 means immediately it displays output. If you give 3 means it delays for 3 seconds, like that. Okay, and release the lock. How you release the lock here? Self dot production dot cv dot release and print it. Okay, yeah, next one everything is same here. This effect, this notify methods and wait method is effective way of communication between two threads. Simple words. Okay, so just use it here. Simple one. Item producer, sleep for 2 seconds here. Item producer. I think you can't different, you can't see much difference here, but if there are so many threads are there, you can observe difference there. Okay, for 4 or 5, nothing negligible there it is. But the effective communication, this is the best thing. Notify all methods. Okay, and also another way is there for effective communication. So nothing but a queue, that is. Okay, queue. Write a Python program that uses a queue in thread communication. Okay, queue class of a queue module useful to create a queue that holds the data produced by producer. Okay, a queue is a first in first out, and queue is a thread safe. So no need of locking here. When locking we have to use threads when the threads are not safe only. Okay, when threads are safe, no need of locking here. So q class of q module, you have to use q class, and if you want to use put method into that class, you have to use what we call um, put methods and the get methods. If you want to put the data in the queue, you have to use put method. If you want to get the data from the queue, you have to use the get method. So how we will put the data in the queue and get the data, we will see here. Okay, so same program only, but no need of all this one. We will see just use, you have to use queue method for this one. Okay, queue module, you have to use queue module for queue import star. Okay, star, you have to use queue module for this one, and just use construct consumer producer, just use self dot queue is equal to, means we are creating queue object here. Okay, queue, so production self, so no need of locking because queues are thread safe here, queues are thread safe, so no need of locking for I in range 5 only. So producing item here. Okay, self dot append I, so no need of all this one. So instead of item producer, so item producer only here, write it I in, and I again I here. Okay, and no need of release. Okay, this one use self dot, we want to put the data in the queue. How you put the data in the queue? This self dot queue dot put method. Using put method, we will put the data in the queue, and the watch data I. Okay, I, and just sleep for 1 second, sleep for 1 second, simple thing. Okay, and next go consumer class. This is a simple thing. Instead of in thread communication notify and other methods, these are the simple one for the thread communication. Okay, same thing, and you have to receive that no data. So you have to receive the data from the production class. To receive the data for I in range 5, okay, print receiving item comma self dot prod dot q dot get method. We have to use get method for to receive the data. Okay, which data in parenthesis I, and everything is same here. Okay, passing, creating an object, targeting, start with starting the thread, creating a thread and starting thread, and creating an object. It's simple, no? Instead of in producer class, you have to write the queue method, you have to put the method in the queue, and you have to write the queue put method, and in consumer class you have to write the get method here. Simple thing. Instead of notify locking and everything writing, this is a simple one, effective thread communication. Okay, see how it fades output. Okay, also there is some problem. Queue empty, item 3, item 4, line 932, exception is 2. Okay, self dot production dot receiving 1 to 10 items from the queue. Okay, from consumer self only. Okay, self consumer class is same. For I in range I, print sleep for 1 second, fine, self.queue is equal to queue. Yep, queue object. Okay, and importing time import star, thread import star, consumer self for I in range 5, print receiving item, self dot production dot queue dot get of I only, item producer also I only. Okay, so I simple put of I only, sleep 1 second only, simple thing. So what's the problem here? Self. So I don't know what's the problem here. So everything is same one, no? It's again. See, item producer 0 1 exception in thread 2, item producer 2. Okay, item producer 0. Line 932. What line 932? 871. Empty. Okay, there is a full method will be there, empty method also there. Full method returns true if the queue is full, either false. Okay, the queue method, the queue.empty method returns true if the queue is empty, otherwise it returns false. And similarly, the queue.full method returns true if the queue is full, otherwise false. The two methods will be there. That's my here. No need of using full method and queue method here. Raise empty, queue empty, item producer, but receiving item it should not showing here. Okay, okay. Right now, so here consumer P. Okay. Sorry. The thing is that no need of this one. It's not the way because before okay. No, because earlier program is working now. Right, like this one 1 2 6. Oh, item producer 1, item producer 2, receiving item 5. It has stuck now. Okay, what's the problem? Sleep 1. Okay. Problem is indentation error. Indentation error means yes, yes. Now we'll get it now. Aha. See, item producer, receiving item 3, 4, 5. Okay, this is the best one. This is the indentation because spaces are important here. I did not see it. Spaces are important here, so this is very good to get that error. Okay, this is output here. Item producing or receiving 1, 2 receiving, 3 receiving. Okay, sleep for 1 second. So This is the best queue is the best one because it's a thread safe and it's easy to write the program here. Putting the method into queue and receiving the thread communication. Okay. So that's about the thread communication. Next thing is a daemon thread. Okay, daemon thread. What is write a Python program to understand the creation of daemon thread? First of all, you have to know what is daemon thread. Threads which run continuously is called daemon threads. Okay, threads which run continuously is called as daemon threads. To make a daemon thread, we use the set daemon true and method or assign true to the daemon property. So sometimes we need to threads to run continuously in memory. For example, let's take internet server that runs continuously and caters to the needs of the clients. Another example is garbage collector that runs continuously and deletes the unused variables and objects while Python program is being executed. Such threads which run continuously are called daemon threads. Okay. Generally, daemon threads are used to perform some background tasks. For example, a daemon thread may send data to the printer in the background while user is working on the other applications. So how we will use thread? Simple. We'll create two methods. One is a normal method. One is a daemon method. One is a daemon thread. One is a normal thread. One is a daemon thread. Okay. So how it fits, we'll see here. Okay. So this is the third one. Just create one simple display method here to display 1 to 5 in every second. So like definition display. Okay, and for I in range, sorry, write it now 5. Print normal thread this is a normal thread. Okay, and okay, and you know end, so the cursor would move to the next line. Okay, and print I, simple print I here, sleep for 1 second. Okay, so that's about the normal method. Next one is, so we'll use time here. Time is there, we no need of queue here, so a little bit doesn't matter what's next display underscore time. This is a daemon thread, and we will just use this as daemon thread. This assign daemon thread to this function. Okay, and suppose while true, print daemon thread. Print c10 and sleep for 2 seconds here and whatever. Okay, and now create a thread here. T is equal to normal thread. Okay, T is equal to thread normal thread for the target is equal to normal function. Okay, normal thread display. That's it. Just start the thread now. T dot start. Okay, next, so apply daemon thread. First create thread here, normal thread. T thread here. D is equal to thread uh, target is equal to display underscore time. Okay, now assign this d thread to the demo thread. How you assign this property d dot demon equal to true. To apply demon, d equal to demon equal to true. That's it. And start the one, d dot start, and observe the output here. Okay. So first in display function executes 5 times and repeats, and display time just it repeats the c time here. Okay, well true demonstrate is equal to, it prints the c time. You know, c time is current time. It produces the current time here. So what's the current time you see here? Okay, see normal thread demo thread 0 1 2 3 4 4. So when see here, observe normal thread demo thread, normal thread demo thread. So it repeats 5 times for the normal thread, but the demo thread don't repeat. Okay, because if the normal thread task has finished, demo thread also it finishes continuously. But I don't want to like that, because so the demo thread is also terminated in this program. To make the demo thread not to terminate, okay, we have to ask the p1 to wait the demo thread completely executes. Okay, not wait for the normal thread, to wait for the p1 to wait till the demo thread completely executes. This is done by using join method. Okay, join method, wait till d completed. We have to use join method, simple. Instead of d dot start, d dot join method. Okay, to execute the demo thread continuously. So it executes the demo. Observe here. See, demo thread 1 2 3, demo thread executes continuously. See, it continuously executes, it won't stop. If you use join method, it demo threads also threads execute continuously, won't terminate. Okay, even though normal thread terminates, the demo thread won't terminate here if you use join method here. Okay, simple. If you want to apply demo thread, just use a demo property here, assign demo property true. That's it, simple. So what is demo thread? Okay, demo thread, what is demo thread? Simple. What is demo? Threads which run continuously is called demo threads. Okay, threads which run continuously is called demo threads. So it will repeat like that only. So we have to stop this one. And okay, I hope you understand this one. So I hope you understand this program. Just practice it. Okay, for how to create thread, how to achieve thread synchronization, how to achieve deadlocks, and how to use that, how to communicate with different threads, how to achieve demo threads. These are the programs, simple programs only, simple concepts. Just go through this multi-threading concepts, and if using the networks multi-threading, multiple processing means if you need to achieve multiple processing, you have to use multiple process. Okay, so go through the theory also. What is thread? What is use of threads, and why what is used for single tasking and multiple tasking and multiple processing. So that's about the threading. Just practice. Okay, that's it.